Alright, so in the textbook today, the assignment's page 433. We're going to do those problems. It's important to kind of show the work and do it on paper, but we're going to be entering them online and submitting it, okay? But before we get into that, so it's going to go all the evens first and then all the odds on that. So, all right, did everybody have a chance to go to page 427 and write the title? Did anybody take a book for the fourth chapter and then also take another book for the fifth chapter? Because we're out of books, so someone must have taken it. So maybe 10 to 15 people took 2 books, I think. So we had to order more for chapter 5, so that was a big fail. People take it. They have extra though, somewhere. What should we do for semester 2? Just take the book in the beginning and then don't ask for another one? Because you know now better what you need to carry with you every day. You probably carry less now than you did in the beginning, first quarter. Okay. Okay, I'm going to move on. Page 427. Here's your title. Properties of rational exponents and radicals. Pretty much what we've been working on. You guys did that handout yesterday. Those were properties of exponents. Today's problems are going to look a little more difficult because the exponents will be fractions. And then there'll be some radicals in there too, but it's the same properties. So we've been reviewing them, but I love this is actually a resource for you that goes through all the properties we've been reviewing. You can see the product property shows that you add exponents. The power property shows them multiplied. Here, both the a and the b get that power of m. The negative exponent goes under 1. You got your 0 property there, subtracting in the quotient property, and then we're going to use this one quite a bit today. If there's parentheses around a fraction, the power goes to the numerator and the denominator. So this is a great resource, especially if you're going to do like open note on the test and you're like, well, I don't remember that one. So fold this page over since it shows all these great examples. And then here's even more great examples. This is the one I want you to copy for bell work. Letter E. Can anyone explain where the 7 comes from in letter E? Shane? 42 over 6. How did they get there, though, with this weird 1/3? I'm going to zoom in on it. So it's 42 to the 1/3, 6 to the 1/3. Since they have the same power, you can pull it out. So they made it a regular 42 over 6, use parentheses, and put the 1/3 here. And then to deal with the 2, they made brackets. So you're allowed to do 2 sets of parentheses. You don't have to make it a bracket, but it does kind of keep it organized. So since they did that, their next step was to actually do 42 divided by 6 to get 7, and then power of a power multiply to get 2/3. One of the difficult things is students feel like they just don't know when the problem's over. Like, I don't know when to stop. So this would result in a decimal. That's the cube root of 7 squared. That's definitely a decimal, so stop. Here you can kind of see that being done as well. It's 4 to the 5th times 3 to the 5th. Instead of making these really big numbers, taking the 5 outside the parentheses and just doing 4 times 3. And then multiplying the exponents. This is the one where students would say, how is that problem done? Like, there's still multiplication in it. How come we don't multiply? What makes this one actually, I think, more difficult than the ones below it is that there's different exponents here. So you distribute the 2 to the exponents and simplify them. And then this is 4 to the 2/3. The cube root of 4 is a decimal. So 6 times 4 to the 2/3 would be a decimal. So they've left it like this, and this really is more simplified than that. So it'll take some time to figure out when and where the problem is over. But that's what's nice about the online is you can check it and see if it's right or wrong. All right, so go ahead and I will open up the assignment to you online. Find the book pages on page 433. If you refresh, you should see it in big ideas. So you can answer questions as we go. You can probably do the first one on your own based on yesterday. So these are the problems on page 433. We're starting with the evens. So this is actually number 2 in your book. And it's number 1 online. It's really good for your comprehension and memory to write the steps down that you're using. So if you want it to become like when you drive the same route over and over and over again, you remember the route. You don't even have to really think about it. You just end up turning right when you're supposed to. That's kind of like this. Just show your work and do it. All right. So here we have a power of a power. So we're going to multiply these exponents. Base 12, 2 times 1/4. So that's base 12, 2 over 4. So that's base 12, 1/2. You can click on letter B there and check it, see if it's right. And that's your number 2 done. If anyone does happen to have 2 books, just bring one back, no big deal. No big deal. It's probably an accident. Ready for number 2? All right, this is number 4 in your book. Number 2 online. I don't like invisible numbers, but they're all over the place, so I'm going to write in that invisible 1. Accuracy. Quotient property, subtract. So we're going to get this down to 1 base 7 and do 1 minus 1/3. Yeah, so 1 is the same as 3 over 3. If you get a common denominator, 3 over 3 minus 1 over 3 is 2 over 3. So this one's letter Z. So same property you've done before, but you have to get a common denominator. Okay, now this one's definitely looking more difficult. We're going to rewrite this because it has the same exponent as 9, 6. And then put the 3 outside because that's equivalent. This is the same as 9 to the 3rd and 6 to the 3rd. I'm not going to forget about that negative 1/3, it's still outside there, but I work from the inside out. So I'm going to reduce. I'm going to reduce 9/6 now. And so that divides by 3, so that's 3/2. So that's really 3/2 to the third, brackets, negative 1/3. And now we got our power properties, so you can multiply. So 3/2, and that would be 3 times negative 1/3. So base 3/2, negative 3/3. Base 3/2 to the negative 1 power. Any questions on all those steps I just said? So we have to leave our answers in positive exponents. So I'm going to put this back into the top and bottom. So this is 3 to the negative 1 over 2 to the negative 1. And negative exponents are really division. So I'm going to rewrite them. This negative 2 actually goes up to make a 2 to the positive 1. And the 3 negative 1 goes down. Since they both have negative exponents, you can swap it. You can flip it. But that's only if they both do. So this ends up being 2 to the first over 3 to the first. Whoops. You have to make your powers positive, yeah. That's how you go from a negative exponent to a positive exponent. So click it and check it. Can anybody unmute their sound so we can hear the right thing? Like, is it muted though? Like, how come we can't hear it? There's no sound? It's supposed to be like, oh, I'm thinking of Khan Academy for sure. It's such a satisfying noise. I click it and get it right. What does it say? Just like green check mark? I think they can do better. Are we ready for another one? A lot of steps. Alright, moving on to number 4. Okay, not bad. What is really common, and I totally get it, so many students, maybe half, are going to write 25 here. Because 5 times 5 your whole life has been 25. The 25 has no place here. Okay, this is not any version of 25. This is not a 5. This is 5 to the 1/2. This is actually the square root of 5. So don't look at this as a 5. This is some decimal. That's not a 5 either. So don't multiply those and make it 25. You have to use the product property and add exponents. Same base, add exponents. So this is 5 1/2 plus negative 3. You can get it down to 1/5 if you add your exponents together. Just like this one. X squared times x to the third is just x to the 5th. And that's adding up the exponents. This one's super visual, so I can believe in it. There's 2 x's and 3 x's, which makes 5 total. Adding those exponents together. It's the same thing here. It's just these numbers are more difficult to visualize. So, and those have a negative 1/4 outside. So, 1 minus 3 is negative 2. So that's 5 to the negative 1 raised to the negative 1/4. And then finally you multiply. And the answer is 5 to the 1/4. I'm surprised they didn't put a 25 in this option list. A lot of people would like that. Ready? Which one are you on, Leslie?
Well, we just finished number 5, but I don't get how one of them is the right answer.
Okay.
Because I went from 49 to 10 over 8 divided by 7 to the 5 and 4, but 10 over 8 is the same as 5 and 4, so subtract to get 2.
You can't subtract if it's not the same base.
Oh,
Ready for number 5?
yes.
Yes. All right, so many great ways to approach this problem. One way that we'll look at in the future is making both of these 7 squared. That's a cool way to do it. I'm not going to do it like that today. Today we're going to practice adding exponents, but if you're feeling like you understand these properties really well and you want to turn these into 7 squareds and try to figure it out, that's kind of good. All right, so I'm going to same base, add exponents. I'm going to just deal with that top first. So make it one big 49 and add those exponents together. Three plus 7 makes 10. And 10 over 8 can be reduced to 5 over 4. So there we go. So these aren't the same base, so we can't subtract. A lot of students thinking this is like 1 in the end, or maybe guessing 7. What we can do is, since the power is the same, we can do like what it showed on letter E, and we can keep the 49 and the 7 in parentheses and put 5/4 on the outside. So pull it out so you can simplify and reduce the 49 divided by 7, which is 7. And it's letter C after all. A lot of people going with letter A. I'm only going to do one more, and then I'll wait and let you guys try them. There's like a duplicate for each one that I did. There's one that looks a lot like it for you to try on your own. That's why it's even and odds. All right, you'll move into these problems that have radicals. The main thing is it the same root? If it's the same root, you can pretty much just combine it and reduce it. If these numbers are different, there's one problem in this assignment where these numbers are different, and it's way more challenging than the rest. If they're different, you have to use some strategy to make things similar. But here, the same roots can become one radical. So I'm just going to make this the cube root, one big cube root, 16 times 32, since they don't simplify separately. Actually, they would simplify. What is it, Isaac? 16 times 32? 512. So that's the cube root of 512. So I added some numbers to this list over here, powers of 3. Any of these that you don't know right now, you should write down. So if you didn't know 4 to the third is 64, write it down. Let your eyes see it. Let your hand write it. 5 to the third is 125. 6 to the third is 216. I never once in class said, write this down 6 times. Make flashcards and memorize it. I never told you to do that. But when I do tell you, if you don't know to write it down, if you just write it down on those days, you're more likely to remember it. So 7 to the third, 343. 8 to the third, 512. There's the 512. 9 to the third, 729. It's your math life is easier if you recognize those numbers. So the cube root of 512 is 8. Here is 8. You guys want some time to work on your own? You can stop for a bit. You guys work on your own. Let me know what questions you have.